Okay, this is a review of sections 10.3 and 10.4, mostly for you people who are out on the biology trip. Hope you guys are having a great time. Tuesday in class, we went over 10.3, which deals with chords and arcs, and that's what I'm going to do first. Then I'm going to do some examples and do an example from the homework as well, showing you how to use trig, and then I'm going to go into the lesson for 10.4. So yesterday, 10.3, we talked about chords and arcs. And the first theorem or property that we talked about says that in a circle or in congruent circles, it can be either or, two minor arcs are congruent if and only if their corresponding chords are congruent. So in the picture, we see that chord DC and chord AB are indeed congruent to each other. So essentially, that makes arc AB congruent to arc DC. So since those two chords are congruent, these two arcs would be the same. So you look at the endpoints of the chords, and that kind of guides you in looking at the arcs that would be congruent. Now I could flip that around, and they could tell me that arc AB is congruent to arc DC, which would in turn tell me that chord AB and DC are congruent to each other. The next property we talked about said that in a circle, if a diameter, and I'm going to put here, or a radius, it could be either or. The diameter or a radius is perpendicular to a chord, and we have that right there in the center. You see they're perpendicular. Then it bisects both the chord and the arc. So because you have a right angle right here, that cuts that chord in half. But it also cuts cuts arc DC in half, meaning DB would be congruent to arc BC. So those would be the same as well. And then the last property we talked about says that in a circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. If you recall back last semester, we talked about if you have a point and you have a line drawn. There are all kinds of routes you can take from this point to this line. I could draw a line here. I could go this way. I can go straight up and down with drawing a right angle. We know that where the right angle is, that is the shortest distance to get to that line from that point. So you want to look for congruent marks and right angle marks. So here, I know that AE and AF are congruent, but I also need to know that they're hitting each of those chords at a right angle. If that happens, then I know that chord BG is congruent to chord DC. In the other picture, I have the right angles. I also need to know that those two pieces are congruent to each other in order to know that the chords are the same. And on this also, you could flip it around. If I know that chord AD is congruent to chord CB, that would tell me that EF and EG are congruent to each other. So you can flip it. So then what we did in class is we went through some examples of how we would use this. So in example 1, I know that this arc and this arc have to be the same. If this piece is 64, then to get the rest of it, I would take 64 away from 360. Then I have to divide it in 2 to find x, because again, I know the blue and the red are the same. So I would subtract, divide by 2, and x is 148 degrees. On problem 2, I know that this chord and this chord are the same because their corresponding arcs are the same. So this arc would be 116 since the chords are congruent. And the 116 goes with this angle x. X is its central angle, and we know that the central angle is the same as its arc. So that would be 116 degrees. Problem 3 was pretty straightforward. These are the same because they're both 4, which means the arcs are the same. So that would be 82 degrees. On problem 4, those chords are the same, which means this arc and this arc would have to be the same. So this is a little bit like, I think it's problem number 1. We have to take 90 away from 360 and divide by 2, and we get 135 degrees. On problem 5, because that arc and that arc are congruent, then the chords have to be the same. So I just want to set those equal to each other, and x ends up being 7. Same over here because this chord and this chord are the same. Those are congruent. So I want to set those equal to each other, and x ends up being 2. Now, if at any point in this you know that if I go too fast and you want to pause and maybe work out some of the problems on your own, you're welcome just to pause the video and then check them. Problem 7, these are both 6, so they're congruent. So I'm going to set those equal to each other, and x is 2. Number 8, I've got them in different circles, but the circles are congruent, so I can still use my appropriate theorems here. So I'm going to set 6x equal to 2x plus 24 because those arcs are congruent, and I get x equals 6. Now in problem 9, this arc is 162. The arc they give me over here is 198, but I can tell that those are the arcs that should be congruent. So what I want to do is I want to subtract 198 from 360, and I get 162. So that confirms that these arcs are the same. So I want to set them equal to each other, and I get 13 for x. Then we went to our other theorems. This was on the back of our practice page, which, by the way, all these practice pages are on Edline, so you can print them out if you did not get them in class. So they're giving us lots of information, and I want to look at my picture first and see which theorem I may be using. I have a radius drawn, which is perpendicular to a chord. I know based on the theorem that that splits that chord in half, so those have to be congruent to each other. And 95% of the time in these types of problems, you're going to end up drawing another radius in your picture to form a right triangle. So I'm going to go ahead and do that. I'm going to draw the radius. And I don't really like how that looks, so I'm going to try to redraw it. Make my congruent mark. And I'm actually going to use my straight edge to help me draw. So I'm going to draw on that radius right there. So they tell me the radius is 13. They tell me RS, which is the whole chord, is 24. Well, I know it's been split in half. That means that piece has to be 12. And that is pointing to that right there. So they asked what RT is. I'm going to start with that. That has to be half of RS, so that's going to be 12. They want me to find TP, which is just this little piece right here. Well, if you notice, you've got a right triangle drawn. The radius in your right triangle is going to end up being your hypotenuse in your right triangle. And so I need to find what x is. So I'm going to use Pythagorean theorem, and x ends up being 5, which is PT. Well, they told me in the directions that the radius, which is this whole thing right here, has to be 13. And I found TP is 5. So if I take 5 away from 13, I'm going to get 8 for the rest of it, which is QT, which they're asking me for in number 3. Okay, in number 4, it's kind of the same type of problem, maybe giving me different pieces of information. I know that that is bisected. So, and they tell me the whole thing is 8, which means each piece has to be 4. They also tell me the measure of this whole arc is 90, which means each piece has to be 45 degrees. And I know that in number 4, they're asking me for the measure of arc DE, which I just found was 45 degrees. They also asked me for FD, which I already found was 4. And now I've got to find AF. So I'm going to follow the same approach I did before. I'm going to draw my right triangle. I know that my radius has to be 6, because if the diameter is 12, half of that would be 6. So I have a right triangle. My hypotenuse is 6. The bottom is 4. And that's AF. That's what I'm trying to find. So I get x as root 20, which most of the time on quizzes and tests, I'm probably going to ask for simplified radical form. So that reduces to 2 root 5. But they asked me for nearest hundredth, so I'm going to go ahead and put that in the calculator. And I get 4.47. In number 7, I'm dealing with the theorem that talks about chords being equidistant from the center. So I know these are congruent because they both have the measure of 6. I've got my right angles. And they tell me the length of chord UV is 3x. TS is 21, so I just want to set those equal. And I get x is 7. Over on number 8, they tell me that these two chords are the same, which automatically tells me that those must be the same. So I'm going to set those equal to each other to solve for x. And I get x is 5.5. So now I'm going to go over, in my last couple of minutes on this video, I'm going to go over one of the homework problems. You had to find the radius, and you had to find the measure of AB. So if I first find the radius, I know this bottom piece has to be 12. Okay, so that's 12. They tell me that's 5. I want to find R. I'm just going to use Pythagorean theorem for that. And I get R is 13. Now, to find the measure of that whole arc, I would need to know the whole central angle. So what I'm going to do is I'm just going to find one of those angles. And then whatever I get, I can double it. And I'm going to use trig for that. Remember, to find an angle, we use inverse. And I've got opposite and adjacent. So I'm going to use inverse tan. 12 divided by 5. And I get 67.38, which if I multiply that by 2, measure of arc AB, I'm just going to round that to 134.8 degrees. 134.8 degrees. So there's the measure of the arc, and there's my radius. So you're going to have to do trig to find some of these arc measures. I will continue with 10.4 on the next video.